Hello, my name is Ted Skinner. I'm Security Practice Architect on Splunk's Professional Services team. I've worked in the InfoSec space for over 12 years and 24 years total in the IT industry, with a diverse background that includes supporting both Windows and Linux systems. I've been at Splunk for over 6 years and specialize in supporting our customers using our security products, especially our app for enterprise security, and this is my Splunk B-Sides talk titled Linux and Windows Endpoint Attack Coverage with Sysmon and Auditd. I want to take a minute and review the agenda for this session. First will be an introduction to the problem statement discussed here, along with an approach and an overview of some of the benefits of my proposed approach. Then I'll cover some background on Auditd and Sysmon, as they are two primary methods used to monitor the host operating systems, both Windows and Linux. After the background, I will talk about the complexity and some challenges introduced by having multiple operating systems in an environment, particularly from a Splunk and instrumentation perspective. Then I'll jump into a lab environment and demonstrate some of the instrumentation work that can be done to reduce the monitoring complexities, and give examples of how searches could be written in a more simple and efficient manner. Unfortunately, that doesn't mean the instrumentation work gets any easier, but it does benefit those analysts using Splunk. Finally, I will show where I've been gathering resources from this research that you can use as well, and wrap up with some concluding statements. Monitoring a heterogeneous environment of systems can be a real bear and quite challenging. Each operating system has its own versions of native event log formats, along with different tool sets to produce and view these artifacts. Despite the fact that similar methods and tactics, as shown by the Mitre ATT&CK framework, are observed on all operating systems, we still find ourselves needing to write different signatures for the same methods, depending on the operating system. Complexity grows by an order of magnitude with each different OS type in the environment. Additional monitoring utilities and log formats are required, along with the additional areas of expertise to get the data into a sim like Splunk and make sense of the data to create actionable alerts and workflows for a group of security analysts. The approach I've been working on to address these challenges is to instrument your hosts and your Splunk deployment in such a way to abstract away the differences in logging formats and tools on each of the different operating systems, so that an analyst or content developer using Splunk only sees the aggregate activity happening on the endpoints in one namespace and format, no matter which operating system the data comes from. The advantage of this approach is that it simplifies the search and rule writing, and even reduces the number of rules and varieties of alerts that need to be created. To summarize the implementation efforts of this solution, I'm leveraging the creation of custom metadata at the operating system level. Then in Splunk, I've created some customizations in the endpoint data model, along with some of the supporting add-ons. In these next few sections, starting with Linux and its Auditd facility, I'm going to do a little dive and give some background on the primary log sources that provide visibility into the goings-on with Windows and Linux hosts. We'll discuss some of the differences and similarities which will set the stage for bridging the gaps. I'll start with Auditd. Auditd is the de facto auditing and logging tool for Linux. It provides a similar functionality that the Security Win Event Log and Sysmon provides for Windows, and is equally dependent on the system's audit policy settings. Auditd requires a configuration of a set of audit rules to generate logs and alerts. There are three types of audit rules. First, we have control rules. These rules are used for changing the configuration and settings of the audit system itself. There are file system rules. These are file or directory watches. Using these rules, we can audit any kind of access to specific files or directories. And last, there are system call rules. These rules are used for monitoring system calls made by any process or a particular user. Due to Linux's approach to representing everything as a simple file, Auditd has a primary strength of file integrity monitoring. Process creation and system calls can also be monitored and alerted on. Auditd's rule coverage is fairly complex, and I'm only simplifying the description of some of the commonly used capabilities here. Next, to move on to Windows systems. Sysmon is a monitoring application from the sysinternal suite of tools and utilities. Sysmon is a Windows system service and device driver that remains resident across system reboots to monitor the OS and writes these system activities to the Windows event log in its own dedicated log channel. It provides detailed information about process creations, network connections, and changes to file creation times. Typically includes a lot of details, even down to file hashes for hunting and searching. Sysmon rules are governed by an XML formatted configuration file that is easy to read and defines any events that Sysmon will watch for and alert on, along with any exclusions such as for particular processes or directory locations. As opposed to Auditd, Sysmon rule syntax is fairly easy to understand. For the purposes of file integrity monitoring, it only has a file create event with no modify event comparable to what Auditd has. It has a file delete event as well. However, there's other events available that cover configuration changes, so there's no real gap. It's just a different implementation on file changes. About a year ago, the MSTIC team published a Sysmon port for Linux. It is dependent on eBPF to run its code inside the Linux kernel. This port doesn't have all the event IDs available that are in the original Sysmon service. However, it is a solid enough subset to cover a majority of what you would need to cover with Auditd. The main gap is with file integrity monitoring events when compared to Auditd. It only contains the file create event and file delete events. And one other nuance is that the log output location is not configurable. All of the event log data from Sysmon for Linux gets lumped in with general varlog syslog output. In this slide, I have listed the 8 different event IDs available in Sysmon for Linux, along with their descriptions. As you can see, event ID 1 is for process creation events. This is the exact same event ID for process creation events on Windows hosts. It is the same case for all of the Linux Sysmon event IDs and descriptions. They're all the same as would be found on a Windows host. It's just that only a subset of the events have been implemented in the Linux port so far. These events may be implemented via a different API on each port of Sysmon, but they all trigger on the same conditions and generate events of the same format. Sysmon for Linux actually shares the same exact schema as Sysmon for Windows. It's just the contents of the fields that'll differ. This similarity is one of the fundamentals I've been using to help bridge the visibility differences in multi-OS environments. I want to wrap up this part of the discussion with a simple high-level comparison of Auditd versus Sysmon for Linux. There's no need for a comparison of solutions for Windows hosts, since Sysmon is the only real no-cost option available for this level of process monitoring. So I'll just touch on a few high-level points of analysis between the two. Auditd is better for file integrity monitoring on Linux because it detects file creation, deletion, and file changes with its watch policy action, where Sysmon will only cover file create and deletion events with event IDs 11 and 23. Auditd filters up to the syscall level, while Sysmon filters are based on high-level events via the eBPF filter driver. However, Sysmon is a much easier and more flexible rule syntax, and the added benefit that the alerts and logs will be the same format as it will be on your Sysmon events for Windows systems. This goes a long way towards reducing complexity from an analyst perspective. Given the choice, it is much easier to instrument the event data coming from Windows and Linux hosts by using Sysmon on both. A lot of those event IDs are already mapped into the endpoint data model with existing Splunk technology add-ons and the Sysmon policy file examples that already exist. There's still a lot of work to be done here, but it's far less work than what is still required to map Auditd logs into the endpoint change data models. But being that Sysmon for Linux is a newer option has recently become available in the last year, in my experience, it's been a harder sell to Linux administrators that I've had to work with, who already had Auditd deployed for years. If you're like me, you end up having to work with what you have, and that means grinding through add-on customizations to make this work, which can be a heavy lift depending on the audit policy files that are being deployed by Linux administrators. Each of these tools and log sources are complex in and of themselves, so taken together can really create some havoc. These sources and event syntax elements are very different from each other, so they create some real challenges when threat hunters try to pivot across them and connect the dots to build a story around what a threat actor might be doing. Splunk searches have to be written in an overly complex manner or broken into multiple searches to deal with the differences of multiple operating systems. This growing complexity puts additional pressure on Splunk from an architecture perspective, with more resources required to run the higher volume of searches or handle longer running searches. We need to be able to offload some of this effort from Splunk to the endpoints themselves, and we can do this by mindfully approaching the instrumentation of the environment. Okay, so after talking about all the ways things are getting complicated when we're looking at all this endpoint data, I now blanketly say, hey, let's now simplify. Now that's a little bit of a misnomer. Believe me, this doesn't ever get to be a non-complex issue. But what we're going to do is use the endpoint data model to aggregate some different endpoint data sources together. We've talked about some of those up to now, the Auditd data, Sysmon for Windows and Linux, and use it to correlate everything together, get some assistance from the Mitre ATT&CK framework to help with some tagging and metadata information. And rather go on and on about this over some slides, I want to jump into a lab environment and show some of the things I've been working on, give some examples, and let's just hop over from here. So I want to start by showing an example of the data sources we're looking at. So we've got the Sysmon for Linux data here. It should look really familiar for those of you working with Sysmon. We've got Sysmon on Windows data. Again, the advantage here is going to be that it's going to be the same exact schema and format, same sort of field names and things. And then the data source is really different is the Auditd logs. So we've got some of the same information. It's just going to be presented in a different format, and you are going to have some different field names. There's a couple common field names that we can map into the data model, but not a ton. As I mentioned before, there's a bit more work that needs to go on there. And just to give you a picture of some of the environment, so I'm going to pull this one of the Windows servers I have in the environment, and just wanted to give you a feel for the Sysmon policy file here. The Linux one, which I'll show you, will be really similar, but we've got this XML formatted document, and we've got these rule groups. They're initially grouped by the event ID for each one, and then we've got rule definitions. So one of the things we've leveraged here is the Mitre ATT&CK tactic names and numbers, and we're putting this information into the rule name field. We'll see this when we do some searches. This is going to help us with correlations, and it's also going to give us some contextual information about the alerts when we see them in Splunk. But this is pretty easy to follow. We've got the rule. We can take a look at the conditions that we're matching on. So you've got the attribute, and then what field contents we're looking at each of the attributes to match these rules. Let me pull over the So we're going to have a very similar policy file here for Linux. The difference being that, you know, some of the rules, because you've got different things that are going to occur on a Linux system. I'm sorry, this is the Auditd policy, so we'll come back to Sysmon. So we can see that the format of the Auditd policy is very different. We have these watch rules that I mentioned, so we're watching this, you know, this directory here. Let me get down to where we have got some of the tactic metadata. So we don't have a field called rule name. What we do have is a key, and you can put any string text you want into the key of each line of the rule. What I've done is I've done a custom field alias on the Splunk side to map this key content into a rule name, and we'll see that when we do some searches, because that'll help correlate the Auditd logs, which are very different to the Sysmon logs. But we've got this rule just for organization purposes grouped into the types of rules we've got. One of the challenges here, I did borrow these from a couple different sources. Go to the top, I've got some credits, and out on my GitHub I've got these references as well. But sort of merge these rule sets together to give some more detections. And one of the inconsistencies are that this the string that's in the key field here, it's different than what we've got in the Sysmon policy. So you can see that the labeling is different. So as some future work, I need to normalize those. That'll clean things up on the Splunk side when it comes through. And then let me pop this back out of the way. And then let me see if, okay. And then I can show this one here. So then this is the policy file that's used for Sysmon on the Linux hosts. Again, I've leveraged the same rule name format. I just have to, you know, continue slowly but surely normalizing some of these rule names with the Auditd key field as well. So that's just, again, continual challenges. And I mentioned that this doesn't ever get any less complex. We're just sort of moving the effort from within Splunk and pushing it more to the endpoints. So after that, the next thing I wanted to take a look at is we've looked at the different policy files. All right. So I wanted to jump in and show everybody the endpoint data model. So here is the definition of the endpoint data model. This comes in the SA Sim app, so you can actually download this from Splunk Base. If you're using enterprise security, it comes wrapped up in there, and it's part of that deployment. But we can see the primary fields. There's documentation out on Splunk Base about which these are required fields. Rule name is something that I added to the data model because I'm using that field to help with correlations in my work. If we take a look at these processes, which is what I've been spending a lot of time lately, particularly looking across multiple operating systems, this process name field is pretty consistently used. So that's been a really important field for me. And that's probably the main field that I'm using as I'm running some of these searches. So let me show you. So we've seen how different this data looks, but we can pull it all together with a data model search, which I've got over here. So this is, we can use the from data model command. The advantage to the from data model command is that you get access to the raw events, but it's just as slow as a normal search. I say this because, with the data being in this data model, we can take advantage of T-stats and run better, more performant searches over a longer period of time. But for this demonstration purposes, it really made sense to, show off the raw logs. So we can see we've got multiple hosts here. We've got a mix of Linux and Windows hosts, all sending data to the endpoint processes data model. I've got the assets populated, so I'm getting some of these additional meta fields about the time sync and update. So that's another framework that we can take advantage of for the data model, is the assets and identities. We have process name, which is in all of the data sources, and we can see we've got the multiple source types. So we've got Auditd and both sets of Sysmon from Windows and Linux. So this is really the aggregation I was looking for when I did my research, and this is what is going to allow us to write less number of searches to capture the same type of detections. So let me dig in. I have an example search I want to copy in just to give a sort of a proof of concept example. Go back far enough to, there we go. Let this run for a minute. So you can see I'm using the role name here to tie some of these things together. We are getting a mix of results from Windows and Linux systems. And if we come down to the rule name, this is, in regard to command and scripting type of tactics. Now I'm still working on policy files. This isn't a real rule that you would write in your environment. This is for demonstration purposes of the power of aggregating these things together. Normally we would either need to run a much more complex search with a bunch of source types and index names in it. This simplifies the search writing process. This right here, I just excluded the Splunk server because we don't need those results in this mix. The idea being here is that if we can use this data model and pull in this process information, any of these threat detections from Windows and Linux hosts at the same time, we shouldn't have to write as many different searches to give us the same coverage, as long as the attributes we're looking for, say we're looking for particular processes or running in particular directories, or any other attributes that are collected. The search writing becomes simpler, and it reduces the amount of processing power on the Splunk side. And that was really the whole start of where this pre-search idea came from. It's deal with the data growth problem that's being thrown at SIMs today. I wanted to come up with a better answer than just throwing more hardware at the system. This effort is in no way reduces engineering efforts in general. It just kind of shifts the effort away from the SIM system itself and pushes the engineering effort back towards the endpoints, which is closer to the source of the data. This results in the data enrichment staying with the data defined by the policy files that exist on the various hosts, and instead of living in lookup files residing in Splunk. It also moves a lot of the data parsing processing out of Splunk and keeps it with the data as well. The normalization of this data will happen in the host-based policy files. This effort requires discipline and cooperation. I know that's not always the case in some of the environments we work at, so this may not be an option for everybody, but for the more disciplined environments who have that collaboration, this is the direction that they speak to in most strategic STEM classes as the direction we're going to move to design and architect SIMs as efficiently as possible. I want to keep digging into this. I haven't even gotten to the point where I've been collecting performance metrics to see if this is worth the effort. That's going to be another area of future research for this. But I just want to give an idea of some of the challenges that I'm still working through. I mean, this, you can see months and years worth of research. Initially, I didn't realize how big of a problem it actually was to work through, but each time, I spend a little more time with it, it gets more and more complex and a problem I want to keep digging into. So I appreciate you listening to me wandering around my lab here and giving a feel for what kind of problem we're really dealing with, the size and the enormity of it. Thank you. So after that walkthrough, you can see there's a lot going on and still a ton of work left to do. I've really only been wholeheartedly digging into this for a few months now, as it's become a issue with some of the customers I've been working with. Some future work that's on the back of my mind here after taking this so far is to look at mapping Bro and Saracata events into the endpoint data model as well, particularly for some of the environments we have where we might not have access to the hosts themselves. There's a lot of telemetry data in these data sources that relate to host-based events that could be mapped in. There's already a project out there that's been started to map Saracata alerts to the Mitre ATT&CK framework, and this could create some leverage to leap off of in this effort. As shown, Auditd, the core set of rules are, some of them are mapped to the Mitre ATT&CK framework, which is really helpful. I want to continue that process, but it is slow and laborious. But definitely want to keep that up. And the new Mitre framework new version of the Mitre framework is due out by the end of this month. So, having to refresh some of this for those additional tactics will be a good bit of additional work as well. In conclusion, the endpoint data model in Splunk can be used to abstract away a lot of the operating system details not needed for initial threat hunting activities and rule writing, while leaving those details available for a deep dive during investigation when it's necessary. It makes sense to create correlations at a higher level so it doesn't matter what the underlying operating system is. A rule name or other tagging and metadata can be used with the Mitre ATT&CK framework labels to correlate activities on disparate hosts without having to write multiple versions of the same SPL search for each of the different operating systems. This does push more of the engineering effort to the instrumentation of data and alert policies on the endpoints, but after that upfront lift, it greatly simplifies content creation and hunting activities in Splunk. As promised, I did put together some resources and will continue updating that. I've got a GitHub repository where I've been collecting my notes and posting some of these Auditd policies I'm working with and Sysmon configurations. And as I continue to customize Splunk add-ons, I'll keep those updated in that repo as well. I want to be able to share this effort. If anybody's interested or has a lot of experience digging into this, please reach out to me. I'll have my contact information out there as well, and that way I can make other people a contributor if this is a passion project for them as well. Thank you for joining me. Hope you enjoy the rest of the B-Sides conference. There's a ton of great information being presented here this week. I look forward to catching a lot of that myself. Thanks again.